Hello, good to see you back. I want to welcome you to the first active component that we are going to examine, and that is diode. So what are we going to learn in this course? First we will see what diode is, then we will move to check what is forward and reverse bias diode, then we will see briefly what's inside of a diode, the working principle of diode, and last but not least we will do a simulation to make sure you understand the theory. So let's get started. Alright folks, as you can see in this image, there are many types of diodes, and the most used one is the generic diode. The Zener diode is the second most popular and we will learn about it in the next course. Then we have the Schottky diodes, LED, tunnel diode and photodiode. What you have to know is that all type of diodes conduct current in one direction, but we will see that they conduct current in one direction only as long as it is operated within a specified voltage level. Anyway, an ideal diode will have zero resistance in one direction and infinite resistance in the reverse direction. Although in real world diodes cannot achieve zero or infinite resistance, instead a diode will have a negligible resistance in one direction to allow current flow and a very high resistance in the reverse direction to prevent current flow. So as an analogy, a diode is effectively almost like a valve for an electrical circuit. So diodes begin conducting current only if the voltage across its two legs is equal to a certain voltage, also called as threshold voltage. So as you can see here, when the forward voltage drop across the diode is very close to this Vf, which is the threshold voltage, the diode suddenly starts conducting current through it. Of course, not very suddenly, but it's true that it's increasing very fast. If you prefer, we can call the forward direction as the low resistance direction, when the resistance of the diode drops to almost zero, so that current can pass through it. So again, the diode is said to be forward biased when the diode is conducting current in this direction. When connected within a circuit in the reverse direction, or we can say the high resistance direction, the diode is said to be reverse biased. So a diode only blocks current in the reverse direction, like for example when it is reverse biased, while the reverse voltage is within a specified range. When the reverse voltage passes a certain voltage, as you can see here, the reverse barrier breaks. So the voltage at which this breakdown occurs is called the reverse breakdown voltage. When the voltage of the circuit is higher than the reverse breakdown voltage, the diode is able to conduct electricity in the reverse direction. I know I said that diode can conduct current in only one direction, and this graph just shows the opposite. But what you have to know is that this reverse breakdown voltage is usually very high compared to the forward threshold voltage, so it's much harder to conduct the electricity in this reverse direction than in the forward direction. And this is why in practice we say diodes have a high resistance in the reverse direction and, well, not an infinite resistance. The symbol of a diode is shown here, and the arrowhead points in the direction of the conventional current flow in the forward bias condition. That means the anode is connected to the P side and the cathode is connected to the N side. Wait a little bit, what is this P side and N side? Well, if we were to represent the internal structure of a diode, it would look something like this. So as you can see here, a diode is formed by joining two equivalently doped p-type and n-type semiconductor. When they are joined, an interesting phenomenon takes place. The p-type semiconductor has excess holes and is of positive charge, while the n-type semiconductor has excess of electrons. At the point of contact of the p-type and n-type regions, the holes in the p-type attract electrons in the n-type material, and hence the electron diffuses and occupies the holes in the p-type material. Anyway, going deep into these holes, electrons, p-side, n-side would go beyond the scope of this lecture, and how a diode works is much easier to understand than the internal structure of a diode. So let's see how they act in real world. Before we get into the simulation part, I want to show you something else. So this is the datasheet of a general purpose diode, and you might have wondered, where does this breakdown voltage or forward threshold voltage come from? Well, every diode is different with different threshold voltages, and these parameters can be found in the datasheet of the particular diode. If we scroll down a little bit, you will see, for example, a maximum DC blocking voltage, which is the reverse biased voltage that, if exceeded, may destroy the diode. And as you can see, different diodes have different maximum DC blocking voltages. And here is the maximum forward voltage, which is 1 volt for this particular diode. And this means that around 0.7 volts, this diode will conduct current very well. At 1 volt, the resistance of the diode will be super small, so all the current will pass through it. So the maximum forward voltage is the highest amount of voltage that can be passed through a diode in a forward direction. However, if this limit is exceeded, the diode is likely to stop functioning at all. Alright, finally, some of you might say this. The truth is, doing practical experiment is much more fun than talking about theory in general. But what can we do? Theory is also an important aspect in learning something. So this is nothing else but a simple demonstration of a diode. As we know, with a resistor, the current and voltage are proportional or linear, and with a diode, current and voltage have an exponential relationship. So we have a DC power supply here, whose voltage can be changed using this slider. Right now the slider is in the middle and the voltage is at 0 volt. So the question is, what do we have to do in order to make this this diode to allow current to pass through it? Well, the voltage drop across the diode from the anode to the cathode must be close to the forward threshold voltage, which is usually at 0.7 volts for general purpose small current diodes. When the voltage is getting close to that threshold voltage, the diode starts conducting because its resistance dropped very much. Now what happens if we reverse bias the diode? The voltage is negative -1 volt, and you can see that diode has very high resistance right now and doesn't allow the current to pass through it. You would have to increase this to a relatively high value until you pass the reverse breakdown voltage, but once you cross the limit, the diode will be destroyed and it will allow the current to pass through even in reverse direction. So this is the end of the course. Thank you for watching and see you next course.